This video covers creating inequalities from a word problem. So just a reminder, if the arrowhead points left, that's a less than symbol. And if the arrowhead points right, that's a greater than symbol. So it's important that you think about each situation and think, do I want something to be bigger or smaller than something else? All right, our first problem says the maximum load for an elevator is 2,000 pounds. Maximum means we can't exceed 2,000 pounds. So far, I know that I need a less than or equal to 2,000 pounds. The total weight of the passengers on the elevator is 1,400 pounds. So we've already used up 1,400 of the pounds. A delivery man who weighs 243 pounds enters the elevator with a crate of weight W. All right, let's list what we have so far. We have passengers who collectively weigh 1,400 pounds. We have a delivery man who weighs 243 pounds, and he's carrying a crate that weighs W pounds. How much can the crate weigh without exceeding? Okay, that's important. Without exceeding means the same as maximum. So we need to not exceed 2,000 pounds. So we need the sum of these weights to be less than or equal to 2,000. Well, from here, what we need to do is simplify, if we can. 1,400 plus 243 is 1,643. Recopy the plus W, the less than or equal to, and the 2,000. Our goal is to isolate W, so we need to do what works. We're going to draw a line at the inequality symbol, and we're going to subtract. The reason we subtract is because 1,643 minus 1,643 is 0. So this cancels, leaving W by itself. Now, if I subtract 1,643 from the left, I also need to subtract 1,643 from the right, and that leaves me with 357 pounds. So the crate can weigh no more than 357 pounds. If it weighs more than that, then the elevator is going to struggle or possibly even have difficulty operating. So as long as we're under that weight, we're good. Next problem. This is one of those straightforward problems. It says 10 less than a number is greater than 32. Now, the reason I included this example is because less than sounds like an inequality word. Is greater than sounds like an inequality word. All right. The less than, 10 less than a number, is referring to subtraction. We saw this subtraction. We saw this in an earlier video. When you have 10 less than a number, it turns the subtraction around. So the number is given by x. We need 10 less than that number, so we need to take 10 away from that number. Is greater than, because of this verb, linking verb is right here, we know that we need a greater than symbol in front of the 32. We're solving for x, so we need to move the 10. We're going to add 10 to both sides because negative 10 plus 10 is 0, leaving x by itself. Greater than, recopied, 32 plus 10 is 42. So any number bigger than 42 will satisfy this particular example. Next example. A sales representative can choose between two pay plans. Plan A pays $300 monthly plus 10% commission on sales. If you're not familiar with the word commission, basically if you're a really good salesperson, that commission is a percentage of the total dollar amount of your sales, which makes your pay much greater. So if you're a really good salesperson, you want to be paid a percentage commission on your sales. Now Plan B pays $1,200 per month. So whether you sell a lot or you sell nothing, you're going to make $1,200 per month. For what total sales would Plan A be better? All right, now let's think about getting a paycheck, and let's think about what better means. I'm assuming that better to all of us means you make more money. So we want Plan A to pay better than Plan B. So that's the first little understanding we have to have. Now let's take a look back at Plan A. Plan A pays $300 a month plus 10% commission on sales. Well, 10% has to be changed to a decimal. Remember what we do. We take the implied decimal point behind the 10 and we move it 2 places to the left and get 0.10. That's 10% on sales, or 10% of sales. So we need to multiply the 10% by sales, which we're going to represent with X. So let X equal total sales. Now this is Plan A. We need that to be greater than Plan B. Well, Plan B is just straight up $1,200. So all we need is a $1,200 on the right. To solve, we need to isolate the X. So we're first going to subtract 300 from both sides. 300 cancels on the left. We have 0.10x is greater than 900 on the right. Now we're going to divide by 0.10. Now why are we dividing? What is 0.10 divided by 0.10? Well, when you divide a number by itself, you get 1. So we have 1x, or x by itself, is greater than 900 divided by 1/10, or 0.1, is $9,000. Now, as a salesperson, if you think you can have sales greater than $9,000 each month, then you want to choose Plan A. You'll make more money that way. But if you're a, less than stellar salesperson, you might just want to go with the safe $1,200 per month. All right, next. 4 more than twice a number is greater than 2/3 of the number. What numbers are possible? This is another one of those problems where you see the words more than, which sounds like an inequality, but it's really indicating addition. Here's the inequality. Is greater than. It's that verb right here. Is, the linking verb, tells you to use a greater than symbol over there. Okay, let's do this. We're going to let X equal the number. And now let's translate. 4 more than means we're increasing something by 4. What are we increasing? We're increasing twice the number. Twice the number means double, or 2 times the number. So we have 2x plus 4 is greater than 2/3 is a fraction, 2/3. Of the number means multiply by the number, which is given by x. What numbers are possible? All right, let's draw a line at the inequality. I'm going to begin by moving the 4 away from the 2x. 4 minus 4 is 0. 2x is by itself, greater than. Now 2/3 x cannot be combined with -4 because they're not like terms. So all I can do is write them side by side. Now notice I have variables on both sides. I need to move the 2/3 x from the right to the left. And I do that by subtracting, because 2/3 x minus 2/3 x is 0, leaving -4 by itself. Greater than symbol still there. 2x minus 2/3 x is 4/3 x. So I'm going to recopy this up here. So I have 4/3 x is greater than -4. And now I'm going to divide both sides by 4/3 because 4/3 divided by 4/3 makes 1, leaving x by itself. Greater than stays the same. -4 divided by 4/3 is -3. So any number bigger than -3 will make this statement true. Next, the ball used in a soccer game may not weigh more than 16 ounces or less than 14 ounces at the start of a match. After 1.5 ounces of air was added to the ball, it was ready to be used. How much did the ball weigh before the 1.5 ounces of air was added? All right, we're going to let x equal the original weight of the ball. Now let's look back at what happens in our problem. It may not weigh more than 16 ounces. That means it has to weigh less than 16 ounces. And it may not weigh less than 14 ounces. Remember that not right there, that negating word. After 1.5 ounces of air was added. Okie dokie. So we started at x. We added 1.5 ounces of air. The ball's now ready to be used, which means it must be weighing less than or equal to 16 ounces, but simultaneously more than 14 ounces. Remember, it can't weigh more than 16, and it can't weigh less than 14. So the weight of the ball is trapped between the lower limit of 14 ounces and an upper limit of 16 ounces. All right, I'm going to recopy that inequality. It's a compound inequality, notice. Recopy that over here so I can work the problem. I'm going to draw lines and my inequalities. Remember, when you have more than one inequality, that means you have multiple parts to the problem. Our goal is to isolate x, so we need to move the 1.5, the 1.5. I'm going to subtract 1.5 because it makes a 0, leaving x by itself. Let me make that blue. All right, so if I subtract 1.5 from the middle, I have to subtract it from the left and from the right. 14 minus 1.5 is 12.5, and 16 minus 1.5 is 14.5. So the ball originally weighed somewhere between 12.5 ounces and 14.5 ounces before they added the air. Next problem says thermostat for a sauna is set to 175 degrees Fahrenheit, but the actual temperature fluctuates. That means varies as much as 12 degrees Fahrenheit. Notice when we say fluctuates, it means it could go up 12 degrees or it could go down 12 degrees. Find the range of possible temperatures. Well, let's go 12 degrees below 175 degrees is 163 degrees. And 12 degrees, because we can fluctuate below or above, 12 degrees above 175 degrees is 187 degrees. So the answer is that the possible temperatures of the sauna are between 163 degrees and 187 degrees. Remember that 175 is sort of like the middle point, and we can go down 12 degrees this way, or we can go up 12 degrees this way. So X, temperature of the sauna, is trapped between 163 and 187. All right, next problem. The senior class is selling lanyards to raise money for prom. The profit from the sale of each lanyard is 75 cents. How many lanyards does the class need to sell to make a profit of at least $250? Let's see, how many lanyards? How many lanyards? This tells us what to let X equal. Let X equal the number of lanyards sold. They want to make at least $250. There's your inequality word. At least means they want to make 250 or more. So $250 is the least amount they want to make, at least $250. The smallest amount they want to make is $250. So we want to be greater than or equal to $250. Now the profit from the sale of each lanyard is 75 cents. So we're going to take our 0.75. We're going to multiply it by the number of lanyards, because for every lanyard sold, they make a profit of 75 cents. So we have 0.75x is greater than or equal to 250. And that's the inequality we need to solve. We're going to divide both sides by 0.75 to make a 1. That leaves x by itself. Greater than or equal to 250 divided by 0.75 is 333.3 repeating lanyards. Now, of course, you can't sell 0.3 repeating of a lanyard, so they need to sell 334 or more lanyards, and they will meet their goals for their profit. This has been a video on creating inequalities. Thank you for watching.